Traditionally, learning from demonstration assumes a demonstration of one particular skill that we want the robot to imitate perfectly. In this work, we would like to move to a more general setup where we are given a set of unstructured and unlabeled demonstrations and we need to segment them into separate skills and replicate all of them. For example, if we had a video of a baby playing with its toys, we could extract all kinds of useful skills such as reaching, grasping, stacking, etc. We base our work on generative adversarial imitation learning by Ho and Armon. As opposed to that work, we have expert trajectories that come from a set of unstructured and unlabeled demonstrations. First, we train the discriminator to be able to distinguish between state action pairs, whether they came from the expert or the robot. The robot gets a reward every time it is able to fool the discriminator. In order to segment the unstructured demonstrations, we introduce the intention variable I that we condition the policy on. The intention is set at the beginning of every episode and kept constant for the time of the rollout. We want the robot to produce different skills dependent on the intention I. In order to encourage this behavior, we introduce the intention network, whose job is to classify which intention the state action pair came from. Both of these objectives, the discriminator as well as the intention network, are included in the reward function of the robot such that the robot tries to come up with skills that are as easily distinguishable as possible so that it is easier for the intention network to classify state action pairs. We evaluate our approach by creating a set of unstructured and unlabeled demonstrations from a mix of expert trajectories. In the first experiment, we train the robot to reach a target. The agent figures out how to reach different targets depending on the intention in a multi-target setup, even though this behavior was not provided by the expert. Next, we evaluate this agent on 4 different targets, and the agent is able to reach every single target dependent on the intention. Next, we mix 2D Walker expert policies for running forwards, backwards, and jumping. From these unstructured demonstrations, our method is able to recover the original expert policies and effectively separate them into different intentions. We extend this experiment to a more high-dimensional system, a humanoid, where the expert trajectories consist of walking forwards, backwards, and balancing. We are able to segment the skills into 3 original policies and replicate all of them. Lastly, we test our approach on the mix of 2 manipulation tasks, grasping a gray block and starting from a block in the grouper, bringing it to a red goal region. From the algorithm's perspective, it looks like a set of single continuous trajectories. Our agent is able to recover both sub-policies, and we can switch between them during runtime to accomplish this hierarchical task.